ሃሎ ትንሽ ጊዜ ቆይተናል ከተገናኘን በዚህ ፎርማት ኤልሻዳይ here so አንዳንድ ነገሮችን እንደ ሪቪውም እንደ ኢንትሮዳክሽንም around the issues of the different computer components low level programming languages like MIPS and C እዛ ዙሪያ important concepቶች ምንላቸውን cover ለማድረግ ዛሬ I'm going to record a series of videos a particular order and እነሱን ቪዲዮ እንደ ሪቪውም ተጠቅማችሁ ከክላስ ኮንቴንቱ ጋር እንድላርጋችሁ I will send out an assignment sometime during this week, the week of the 23rd ማለት ነው. So in this video cover የምናደርገው memory ነው. Let's do memory. Computer memory, different issues around memory. So memory scenario, we're really talking about storage of what? Data and instructions. Like normally memory is not associated with narago or particular data like like characters, it could be like text, in general images ምናምን የሆነ statically store የተደረገ ነገር ብለን ነው የምናስበው ግን we should also think about instructions like program codeም የሆነ ቦታ store መደረግ አለበት execute የሚደረጉ ነገሮችም የሆነ ቦታ store መደረግ አለባቸው so when we're talking about memory we're just talking about the space available to a computer to like store, transfer, move around data and instructions. Okay, so there's two types of memory. So memory sinanagar. One is registers. ሁለተኛው is just referred to as memory. Yeah, your program memory. No? Like we can say program memory. Here, ምንድነው ልዩነታቸው? With registers ምንጠቀምባቸው it's for immediate use, direct use by the CPU, central processing unit. ስለ CPU እንግዲህ ስለ ኮምፒውተር መማር ስንጀምር ገና መማር ምንጀምረው ስለ like CPU central processing unit ማለት any sort of computation, any like ድርጊት የምንለው ነገር, any execution of an instruction happen የሚያደርገው CPU ላይ ነው. ይሄ CPU ኢንስትራክሽኖቹን execute ለማድረግ access ማድረግ ያለበት ዳታም ሆነ የኢንስትራክሽን ካለ that should be available in the register. ከሬጂስተሩ ጋር ነው direct communication ያለው, right? So the register የምንጠቀምባቸው ልክ CPU execution ጋር ስንደርስ CPU access እንዲያደርግ ምንፈልጋቸውን any sorts of things register ጋር እናደርጋለን. So ለCPU መጠቀሚያ ነው register ማለት ነው. When we come to program memory ይሄ ደግሞ it's space available to a running program. A running program ማለት አንድ ፕሮግራም አለኝ አይደለ የጻፍኩት ኮድ ሊሆን ይችላል anyway አንድ ሰው የጻፈው ኮድ ኮምፓይል ይደረጋል አሴምብል ይደረጋል whatever መጨረሻ ላይ it will be in a runnable version አይደል executable ኮድ ይሆናል ያንን run ማድረግ ሲጀምር run ያደረገ ያለው ፕሮግራም available ያለው space that's the program memory የሚለው right so ልክ እኔ run ማድረግ ሲጀምር ለምሳሌ አንዱ calculator program search calculator program run slow the minute it starts running the minute it starts doing the things it's supposed to do maybe asking me for numbers maybe adding like numbers I gave it whatever if while it's running yellow and available yellow space program memory ይባላል so that's the difference registering ከCPU ጋር ነው ያዘው what's available to the CPU directly ከዛ program memory ደግሞ what's available to a running program directly ከዛ it's same thing data and instructions ነው እዚህ ጋር እዚህም ጋር we're dealing with data and instructions ከዛ ውጪ ምን አለ right so this exists on the CPU registers now another facet about them it's smaller right compared to program memory which is generally larger የበለጠ ነገሮች ስቶር የምናደርገው program memory ነው and logically ስናስበው right CPU immediately ዛች ጋር execute እያደረጋት የሚፈልጋትን ነው የሚያስፈልገው so አሁን like አንድን like ሁለት small piece of computation ስሰራ ወይም small piece of instruction execute ሳደርግ የሚያስፈልጉኝን ነገሮች ብቻ ማስቀመጥበት plate it's smaller than the entire running program ሊያስፈልገው የሚችለው allocate የሚደረግለት space ማለት ነው። So that's like program memory is larger, registers are smaller. Another thing is registers are faster. Access storage operations ይፈጥናሉ with registers compared to memory, program memory. It's slower, right? So with registers demo, they're located on the CPU. And with MIPS CPU, generally, MIPS ማለት ያው like the assembly language that we're working with in the class already ጀምራችኋል ስለሱ መነጋገር. With MIPS, we are talking about 32 registers ናቸው ያሉት available to the CPU. Each register stores 32 bits of data. Right? ማለት 4 bytes ማለት. 4 bytes is also known as a word. One word. One byte is 8 bits. So አንድ register 32 bit አለው, which means 4 bytes, and 4 bytes አንድ ላይ one word ይባላሉ. So each register stores a word. 32 registers አሉን in MIPS. Now these are just ቁጥርስ. It's good to know when you're working with MIPS ምናምን ማለት ነው. With memory here, like another thing to mention, it's virtual. እዚህ ፖይንት ላይ ብዙ ድዌል አላረግም because ያው ለእናንተም ድዌል አታርጉ ትንሽ confusing ሊሆን ይችላል at this stage before you've had a lot of experience working with computers. Then the idea is there's a particular structure program memory ማለት ነው. With program memory, let me just change colors to talk about program memory. There's a certain amount of like space allocated for a running program. That's what program memory means. ይሄ dedicated ለዚህ ፕሮግራም ይሄን ያህል ስፔስ ሰጥተናል እንደዚህ እንዲያረግበት የምንለው ማለት ነው. Usually in like C run የሚያረግባቸው operating systems and C programs in general 512 GB ነው እንበል. Right? ከዛ እዚህ ጋር 0 ብሎ ይጀምራል እስከ 512 GB ድረስ ይሄዳል gigabytes. Now there's a certain way that space is divided up when like architected. At the top we have OS, OS related code and data. The operating system like the operating system dedicated no but operating system related things ናቸው ከላይ ያሉት. At the bottom, at the very bottom ደግሞ program code አለ, which is the program you're executing. ራሳችሁ የጻፋችሁት execute የምታደርጉት program ማለት ነው. Like because we're talking about a running program here, right? run እያደረጋለው program የሱ code set of instructions የት ነው የሚቀመጡት? At the bottom here. And then look ከዛ በላይ we have the static section of memory. Right? And this will be more clear as we talk about like in different types of variables in C, global staticoች አሉ. But essentially this is a particular type of memory የሚቀመጥ ማለት ነው. Right? ከላይ look ከዚህ ቀጥሎ we have the stack. And then ziga we have the heap. These are the most important things in my opinion. I want to start paying attention to the stack and the heap. And their differences, the stack, it grows downward. ወደ ታች ነው የሚያድገው. ልክ ለምሳሌ when I add something to the stack እንደዚህ ያስቀምጣለሁ, and then ሌላ ነገር ስጨምር እንደዚህ ጨምራለሁ, ሌላ ነገር ስጨምር እንደዚህ ጨምራለሁ. ወደ ታች ነው upside down ነው stack እየተደረገ ያለው. remove ሳደርግ እንደዚህ remove አደርጋለሁ, ከዛ እዚህ ጋር ቀጥላለሁ ምናምን. Right? And the stack, generally it's temporary data የምናስቀምጥበት ነው. So examples of things that are put in the stack are like ለምሳሌ temporary variables in C programs ልክ አንድ function ውስጥ ስትገቡ ለዛ function use ብቻ የሚፈጠሩ variables ወይም different like function calls return ሲያደርጉ ከስታክ ላይ remove ይደረጋሉ አንድ function ውስጥ ስንገባ ስታክ ላይ ይጨመራል so temporary ነው and another important thing about it is auto managed and then with the heap is more dynamic, dynamically allocated. Essentially, this means running programu እየፈጠረ ያለው space ማለት ነው. And in that light, it's not auto-managed. It's managed by you or whoever is developer in below. Whoever is in charge of the program code has to have put something in there that will manage the heap. And the heap is long-term still relative to like the amount of time the program is running, but it's less temporary than the stack, and it has more space, right? Because the stack is limited compared to the heap. The stack runs out. And I've run personally into issues where stack ላይ በጣም ብዙ ነገር ይቀመጥና ፕሮግራሙ ክራሽ ያደርጋል. The stack space ሞላና አለቀ ተባለ. So if you know there's something is going to be big, large, you want it to stick around for longer because you want to be in charge of how long it's there, ምናምን, you'd want to put your data on the heap. And then otherwise you put it on the stack. ያው ሲ ፕሮግራም ላይ ወደ መጠቀም ስትጀምሩ ነው እነዚህ ነገሮች የበለጠ ሴንስ የሚሰጡት because with C you are able to dictate whether or not something is on the stack or on the heap and that's why C is called a low level language ከሜሞሪ ጋር intertwined የሆነ ቋንቋ ነው with Java doesn't give you a choice of where things are. Java is a language that is very controlling about how it uses memory like memory leakoችን ለማቆም so memory leak ማለት ለምሳሌ just a small aside heap ላይ ሆነ ቦታ ይዛችሁ if you're not responsible enough to deallocate heap ላይ ተጠቀማችሁትን space when you're done with it and the program exits out and that space ተቀምጦ መቼም እንትን አልተባለም that's known as a memory leak ፕሮግራሙ like memory allocate አድርጎ መቼም deallocate ሳያደርግ ተይዟል ግን አልተያዘም አይነት space situation ፈጥሯል and with computers this is very bad like over time you might run out of space and when with Java like garbage collector የሚባል ነገር አለ Java ውስጥ everything is put on the heap but there's an automatic machine ከላንጉዌጁ ጋር ዲዛይን የተደረገ no longer in use የሆኑ ዴታዎችን deallocate የሚያደርግ መልሶ right so these are the differences between different languages as well ቋንቋዎች ሲንታክሳቸውና how you write them ብቻ ሳይሆን የሚለያዩት they are different fundamentally in how they interact with the underlying computer underlying hardware the operating system etc so just to recap ከዜሮ ጀምሮ እስከ however many space ላይ ድረስ ይሄዳል the memory 512 gigabytes no ካለን and then at the bottom we have the program code ከዛ static እንትኖች አሉ ይሄ global variables literaloች ምናምን የሚቀመጡበት static section አለ and then we have the heap that grows upwards more permanent larger data dynamically allocated ራሳችን manage የምናደርገው section of memory ከዛ በላይ there's the stack that grows downwards ወደ ታች የሚያድግ for more temporary storage auto managed by the program computer and then ከዛ በላይ we have the operating system stuff at the very top አሁን virtual የሚለው ነገር ላይ እንመለስ ለምንድነው virtual ያልነው this isn't exactly how computer hardware ላይ the space is laid out this is a conceptual or ideal representation that is fed to the running program ለrunning programu front እንሰጠዋለን okay run እያደረክ ያለው program 512 GB space አለ space orchestrate የተደረገው or design የተደረገው በዚህ diagram መሰረት ነው እንለዋለን the program uses as it needs right there we aren't really giving the program 512 GB actually የለውም with the ተስፋ that it won't use now you give it the illusion of space and a particular architecture for how that space is laid out and the program goes accordingly that's why we say it's virtual because there are like memory mappers operating system ውስጥ that kind of actually map ይሄንን ስታክ አካባቢ ያሉትን ሂፕ እነዚህ የተለያዩ memory sectionዎችን to actual memory locations on the computer hardware. But again, you can read up more on it if you're interested, but generally ማስታወስ ያለባችሁ like how program memory እንዴት ነው ዲዛይን የተደረገው in terms of the different sections, the general purpose of the different sections, and that the relationship between program memory and registers የሚለው ነው. Okay, so we have this. Let's have different colors ለተለያዩ sections. The stack is red. አይታይም ግን አይ ቢቀር ይሻላል ከለሩ እንግዲህ ከሳቃችሁብኝም ሳቁብኝ. I will maybe send out an actual diagram with በትክክል ከለር ያለው for everybody to refer to. Okay, ከዛ we have now we can talk about registers in more specificity. Essentially we should remember that registers are for use by the CPU at the time of executing a particular instruction, right? And really like the thing to remember now as we enter the world of using an assembly language like MIPSን ተጠቅመን executing የሆነ program እንሰራለን የሚለው ደረጃ ላይ ስንደርስ there are particular spaces conventionally used for particular purposes. ምንድናቸው እነዚህ? Like different registers, they are named እንደዚህ $sign letter ምናምን ነገር ስታዩ these are like names for easily remembering particular registers. እና conventionally የተለያዩ named registersዎችን በቁጥር ነው in reality like $0 እያሉ ነው refer የምናደርግባቸው, but we will use a combination of letters and numbers to remember them easier. And we can do that in MIPS as well. And conventionally የተለያዩ ነገሮችን የተለያዩ registersዎችን ለparticular purposeዎችን እንጠቀማለን, right? So the register V0 ለምሳሌ whatever we put at this register, if we put in an instruction ለምሳሌ we can access it during a system call. Syscall. During a system call እናርግ ስንል in MIPS for example it expects the system call to exist at this location. So እዚህ register ውስጥ የምንፈልገውን instruction ካስገባን በኋላ system call ስንጠራ ያ instruction execute ይደረጋል. But there are in general ከV0 እስከ V1 ያሉት ደግሞ apart from that they're used for subprogramዎች instructionዎች value return ሲያደርጉ at these register locations ነው የሚያስቀምጧቸው. And then ከA0 እስከ A3 A0 A1 A2 A3 እነዚህ አራት value registers they're used to store arguments that are passed into like program calls, subprogram calls, or subroutines or instructions, whatever you want to call them. So እነዚህ arguments ናቸው, እነዚህ return values ናቸው. So in the function arguments አስቧቸው argumenቶቹን የመጀመሪያውን A0 ውስጥ ሁለተኛውን A1 ውስጥ ምናምን አድርገን and then instruction ስንጠራ ያ instruction retrieves the arguments from these register locations ማለት ነው. And then we have ከT0 እስከ T9 ድረስ እነዚህ temporary values store ለማድረግ የምንጠቀምባቸው. And with experience we'll see how to use these temporary values and why they're important. And then we have ከS0 እስከ S8 ድረስ መሰለኝ, correct me if I'm wrong, check these, to store saved values. And these are the values that these are the values that essentially longer store የምናደርገው. They're not going to be overwritten by like other automatic other instructions automatically ምናምን like በደንብ like እኛ retrieve እስክናደርገው ድረስ ምናስቀምጠው or እኛ overwrite እስክናደርገው ድረስ ማስቀመጥ ምንፈልጋቸውን store ማድረግ ምንፈልጋቸውን values at these locations ከS0 እስከ S8 ያሉት register ውስጥ እናደርጋለን ማለት ነው. So just keep this in mind later on when we're looking at MIPS MIPS code and analyzing what it does, now understanding the language better. There are particular registers conventionally like agree argan lazy purpose እንጠቀማቸዋለን እና these are some examples of them. There are others, ግን ያው these are the most common, at least at entry level ወይም introductory level MIPS እንጠቀም ማለት ነው. Okay, so we've talked about all of this stuff regarding memory. So now we can talk about data types. Data types, which we already have, and now like data types with regards to in C and MIPS, how we use them, how we refer to them, access them. Oh, I don't know what's happening. Okay. Access them, etc. Right? So back then, መጀመሪያ ላይ ያኔ ስለ data types, data representations እናወራ, we talked about how data was a type, the concept of a concept of a type is a combination of data and interpretation. And with data we have how much, right? Which is size. So with this in mind, you know, in data types already cover አድርገናቸዋል በብዛት, ግን ያው ከሳይዝ ጋር with these particular languages like C እና MIPS ምንድናቸው ብለን እኔ like, okay, so first we know about char, the character type, right? The character type in both C and MIPS is 1 byte. Okay, and the byte, and the 1 byte of to represent the character we need 1 byte of space. All right, now we have integer, or the int data type. For this, and in C there's like different integers. We have like integer types. We have short, int, long አለን። እነዚህ essentially like determine የሚያደርጉት what's the range of integers we cover ማለት ነው. If you remember, whenever we talk about ለምሳሌ 50 የተለያዩ ነገሮችን represent ለማድረግ ስንት ቢት ያስፈልገኛል፣ 200 የተለያዩ ነገሮችን represent ለማድረግ ስንት ቢት ያስፈልገኛል እያለን አውርተናል አይደለ? We talk about how to enumerate a certain amount of things we need a certain amount of bits እና 2 to the power of ምናምን እያደረግን ያን number determine እናማድረግ. We've also talked about the range of numbers, for example, that an 8-bit 2's complement representation can cover ምናምን, right? So short, int, long ነው ሁለት long. እነዚህ ነገሮች differentiate የሚያደርጉት between ranges of integers covered. So long covers more integer ranges. So if I want to do a very high number, it might be that I can represent that using a long but not with an int, because long higher numbers እና much lower numbers and cover ያደርጋል. So በምንም ይለያያሉ? in their size ይለያያሉ, right? Because obviously to represent an int I need less bits than for a long, because a long covers more integers, right? So በሳይዛቸው ይለያያሉ. So for now, for simplicity, we'll just talk about int, the most common one. And with int, I would need 4 bytes. 4 bytes both in C and MIPS. Similarityያቸውን እያያችሁ ነው. Like this is very convenient for us. Similar መሆናቸውን. 4 bytes is also known as one word. And word 4 bytes no. So that's with integers. And now we come to the very interesting part, string. Strings and arrays, and we'll see in a minute just a bit, are very, very, very important in C. Now, real conceptual complexity ወይም richness-ን as you know progress in your computer science education የበለጠ appreciate እያደረጋችሁ ትሄዳላችሁ. But with strings ምንድን ናቸው ስንል a string is just an array of characters with a null terminator. Each part በጣም important ናት. Each part በጣም important ናት. What do I mean by this? Normally, in any programming language, string ብለን እንጀምራለን, right? When we talk about a string, ለምሳሌ a sample string is hello, right? This is a nice string. So how is this data represented? ብዬ ስጠይቅ what did I say? It's an array of characters with a null terminating byte. So let's say I have an array. Right? And h ሁለት e 3 4 5 5 ካራክተሮች አሉ እዚህ string ውስጥ አንድ ቦታ 2 3 4 5 አንድ ትርፍ ቦታ አስቀምጫለሁ at the end. We're about to see why in just a second. So I have an array here, right? Array length is 6. የመጀመሪያ ስፖት ላይ h ትገባለች ከዛ e ይገባል ከዛ l ይገባል. Sorry, small letter ነው አይደለ because there's a difference. እንደዚህ እዚህ ጋር ምንድን ነው የሚገባው እዚህ ጋር የሚገባው null terminator ነው በካራክተር ባክስላሽ እንደዚህ አድርገን ማስቀመጥ እንችላለን በአስኪ ኢንቲጀር representation is just 0 አስኪ ቻት ላይ ሄዳችሁ 0 ምንድን ጋር ነው ማፕ የምታደርገው ብትባሉ null የሚል ታያላችሁ ወይም null terminator. What is this saying? Anytime ልክ string ሲያልቅ አንድ ቦታ ትርፍ መኖር አለበት መጨረሻ ላይ ማለቁን የሚያሳይ null terminating byte ማለት ነው. One byte of a null terminator የሚጠቀምበት. So anytime we have a string, the length of the array representing the string is the number of characters in the string plus 1 for the null terminating byte. ሁሌ represent ማድረገው እንደዚህ ነው. Just to see another example, hi ካልኩኝ I have 1 2 space character 3 4 5 and then I have one additional for the null terminator 1 2 3 4 5 6 right? So I do h I space there's a I don't know character representation I think 13 ምናምን integer representation but less space and be bad on little h I and then እዚህ ጋር null terminating byte አስቀምጣለሁ and that is my array. So this is what we use in essentially most programming languages have a kind of correlation or mapping between a string and an array of characters, right? Because ብዙ ጊዜ I can access the character within a string using array syntax. ለምሳሌ እንደዚህ ሳደርግ እቺ ምንድን ናት at index 2 ያለ of this array ነው የሚለኝ at index 2 ምንድን ነው ያለው 0 1 2 l ነው ማለት ነው. So there's a correlation, a very strong correlation between arrays and strings, and in C especially, but strong correlation between arrays and string. And now there's an essential thing ከዚህ ቀጥሎ የሚመጣው which is how do we refer to things, how do we refer to data, how do we pass around data, how do we allow instructions and programs and whatever to access data የሚለው ጥያቄ ላይ there are two important concepts called pass by reference versus pass by value. ብዙ ጊዜ ፋሚሊያር የምንሆንባት እኛ pass by value ነው ለምንድን ነው pass by value ፋሚሊያር የምንሆንባት ኖርማሊ ለምሳሌ variable ስንፈጥር አይደለ let's say Python እየተማራችሁ ነው. I could be like, I think this is the syntax for Python. var, maybe not. I think this is JavaScript. ይምታቱብኛል አንዳንድ ጊዜ. But let's say this is how could do let x equal 3. አይደል? Anywhere ለምሳሌ x plus 3 ስል, or anywhere I like pass in x to a function, I'm throwing this value around. አይደለ? እዚህ ጋር 3 ነው አስገብቶ 3 plus 3 ነው የሚያደርግልኝ. print ስለው x 3 ነው የሚገባው into the print function to then appear out on the console, right? Whenever I say x, I'm talking about the value underneath x, which is 3. That is what we mean by pass by value. Pass by reference again, I can, instead of, let's say, 3 sil አሁን ለምሳሌ x equals 3 sil 3 የሆነ ቦታ ሜሞሪ ላይ አለች. And anything that, whenever I throw that string, the value at that memory address, no, I'm throwing it around. አይደለ? However, let's say this is memory location 0003 እንበል. That's not how actual memories are referred to, but let's say like that's the label, memory location. Instead of saying, instead of throwing around x, which is the actual value at this location, I can throw around the memory location, right? So I could say let and declare a variable called address x equal 0003. This is not real code in any language. I'm just conceptually understanding it. So እቺን address save አረጋትና የማንን address የስሪን address, then I can throw the address around. So ለምሳሌ ለprint, if I had a version of print that accepted, instead of the actual value, an address of a value, then it could say, I'm just telling print at that moment ምን እያልኩት ነው? ሄደ እዚህ address ጋር ያለውን value ተጠቀምና እሱን print አርግ. Right? Location መስጠት ትችላላችሁ. This is similar as saying ውሃ ፈልጋለሁ ብዬ ጠየቅኳችሁ አይደል? እኔን ሳቲስፋይ ለማድረግ either ውሃ ይዛችሁ ሊመምጣት ትችላላችሁ, or የውሃ ሎኬሽን ይዛችሁ ሊመምጣት ትችላላችሁ. እዛ ሼልፍ ላይ ውሃ አለልሽ ስትሉኝ አድሬሱን ነገራችሁኝ የውሃውን ማለት ነው አይደል? በሬፈረንስ ዲሊቨር አደረጋችሁት ውሃውን ስታመጡልኝ ደግሞ በቫልዩ ዲሊቨር አደረጋችሁት. ምንድነው ልዩነቱ? when we talk about, when we follow this analogy to talk about, ለምሳሌ አንድ benefit of passing an address around versus the actual value itself, ቁምሳጥን ፈልጋለሁ ቢሆንስ ያልኩት ለእናንተ ቁምሳጥኑን ብድግ አድርገው አምጥቶ ለእኔ መስጠት ይቀላል ወይስ ቁምሳጥኑ ያለበትን ቦታ ለእኔ መናገር? ያው እዛ ጋር ያለልሽ ቁምሳጥን, right? So አንዳንድ ጊዜ when the data is big and clunky, it might be easier to just refer to it, የት እንዳለ መናገር ማለት ነው. And when we talk about strings, why is that important? Usually in C, ስለ strings ስንነጋገር ምንድነው we're talking about when we pass around strings, when we try and allow other things to have access to a string we've created, because we're using several different characters አይደለ? like ለምሳሌ h e l l o ከዛ እንትን አለ እዚህ ጋር 6 ነገሮች አሉ እያወራንባቸዋለሁ በኤንቲቲ መንገድ እያወራን, or like size of a string is like እንትን አይደለም definite አይደለም. When I talk about a character string ስላችሁ, you always know that it's going to be 1 byte. Integer string ስላችሁ, if it's an int, you always know that it's 4 bytes. String ስላችሁ ግን you don't know the size of the string. It depends on how many characters are in that string. If I'm talking about a string that Romeo and Juliet Shakespeare መጽሐፉ እንዳለ በአንድ string represent ከተደረገ, that's one very large string. ስማችሁ ከሆነ it's one smaller string, but you don't know, it's not determined, right? So then what you usually do, instead of passing around the entire string, what we do in C especially is we pass a reference to the first character in the string. So in hello mil string ስጡኝ ስላችሁ, you give me the address of h, the character h, the first string. So anybody that has the address of h, ከh ጀምሮ እስከ null terminator እስኪያገኝ ድረስ ይቆጥርና that's the string I have there ማለት ነው. You see the value of the null terminator? Null terminator binary, I'll just be hopping through memory forever, right? I don't know the end of the string. But the end of the string exclusively is used for the end of the string, the null terminating byte, the 0 integer value. So anytime I want to talk about a string, I pass it around by reference, which is I refer to the first character. I give the address of the first character. And in C, there are special variables that hold memory addresses. And these are called pointers. A pointer is a variable that holds an address, a memory address, as its value. So min shallow in the case of hello, a pointer that holds the address of the character h, which is the first character in the string. H kalletching, I just keep going through the string, through the characters until I reach the null terminator, and then I know, right? So let's say I have an example here. And then memory address ochu. Okay, let's say we have this, right? Let's say actually lemon Anthony, yeah, I don't want to ruin the language, but let's say natural language لصافة. Pointer A has value 0x2, right? Itchin in as a string sanabat. እንዴት ነው ማነባት? 0x2 መሽጋየቱ ጋር ነው ይሄ ነው አይደል? it points to e. so ከe ጀምሬ እስከ null terminating byte ድረስ ሄዳ አነባለሁ ማለት ነው። e l s h u ከዛ null terminating ነበረ l ሹ. that is the string represented by the pointer a. what about if a had value 0x5? then የቱ ጋር ነው የሚጀምረው? እዚህ ጋር ነው የሚጀምረው። so h u. so then a refers to the string who. and then what if a has the value 0x7? then 0x7 is just the null terminator አይደል? ምንም ነገር የለውም። so it's just the empty string. what if a has the value 0x8? then እዚህ ጋር ነው ያለው k አለ u አለ then the null terminating byte አለ cool. that is the string represented by a, which is a pointer that is pointing or has the address value 0x8. That's what we mean by how strings are represented. So this is very important. I recommend you do additional reading. Different resources are out there about memory, the different sections of memory, registers and how they work, different data types, strings and pointers in relation to memory, and how they work in general. But yeah, so that concludes this video, and then the next video will be covering MIPS code in general, and I will do some in-depth look at each one of the MIPS instructions, what they're doing, how to understand them. Okay. Thank you, everyone.